Okay, today we are doing Pythagorean Theorem, some word problems, some application, and you're doing section 11.8, page 515, 1 through 9, and 14 through 16. It was 1 through 9 and 14 through 16. All right, so today we're looking for finding the missing sides of a right triangle using our Pythagorean Theorem. So if they set you up into nobody's going to tell you to use Pythagorean Theorem, but if you see yourself and you can create a right triangle, then you know you should utilize, an alarm should go off in your head that says that you should be utilizing the Pythagorean Theorem. So let's go. As we know, our right triangle is made up of two legs and a hypotenuse. So if we do leg squared plus leg squared, we end up with our hypotenuse squared, the value of our hypotenuse. Sometimes we call it a squared and b plus b squared, where a and b are interchangeable. Those are the legs, equals our hypotenuse. All right, so if they give you a right triangle on a grid, we can see that 90-degree angle there because of the grid paper. You can actually count the units. So the units, each block, if this is 1 centimeter, this is 1 unit. 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. And the other one would be 8 units. Okay, now knowing that we are here, we can find our missing side, which is our hypotenuse, and utilize, okay, I'm seeing some people in the homework are not writing a squared plus b squared equals c squared. I need you to write that. That's what I'm looking for in your homework for each problem. Okay, so I have a squared plus b squared. I'm substituting in 6 squared plus 8 squared equals x squared. We end up with 36 plus 64. Add those two up. We end up with 100. We root both sides, and we end up with 10. The measurement of side x is 10 units. We can't have remember when we take the square root, we end up with the absolute value. We get two values, so our root is 10. Can't have a negative distance. All right, pause the recording and you try the next one on your own. Now let's check it. Let's go to our first side. Our vertical side is 4 and our horizontal side is 7. So we're substituting in 4 squared plus 7 squared. We end up with 65. We root both sides. And so in your homework, if I don't say estimate, I don't expect you to estimate. Or on tests, you should be reducing your radicals. I have a lot of people that really haven't proven to me they know how to reduce radicals because they estimated everything. And I know if you have a calculator next to you, then you're not really doing the work. So we're looking for reduced radicals. With these application problems, we do want you to estimate, because if we're looking for a distance and you needed to order some materials for that, I just wanted to bring that up. So it's about 8.1, 8 1/10. Find the missing side of the right triangle in the 1 centimeter. This time we are given, we are still given, sorry, I don't know what I was thinking. So we've got 5 and 12. Okay, you guys pause it, finish it up on your own. Now let's check our work. You should have had x is equal to 13. That's one of our Pythagorean triples. All right, this time they're giving us the hypotenuse. So I want you to try it, knowing that they gave us the hypotenuse. Go. Now let's check our work. You should have set 10 up to be c squared. Doesn't matter where 4 and x go. They are interchangeable. We have to square both of them. We have to simplify our exponents first, subtract 16 from both sides, and now I'm left with the square root of 84. So if I were going to reduce this radical, I have to pull out perfect squares. 4 goes into that. 16, I believe, goes into that. So let's see. 16 goes into 84. Oh, no, it doesn't. Let's see, 84, I believe it's divisible by 8. No? Well, I know 4 goes. 4, let's try that again. 84 divided by 4, I can break that down to 21. So, well, okay, that was ridiculous. So, if I break that down to 4 and 21, 4 times 21, and that means 2 rad 21. Or we can take the square root of 84. Or we can take the square root of 84. It falls between 81, which is 9, and the square root of 100, which is 10. This is 3 digits away. This is 16 digits. So I'm going to say like 9.1, 9.2. So I'm doing my second square root of 84, and I get 9.16. So either of those were good choices. X is about equal to 9.1. Okay. 9.2 I would have accepted. 9 2/10. All right, let's see what my PowerPoint did. They called it 9.2. They rounded up because it's 9.16. All right, try the next one on your own. Now let's check our work. Substituting in. We have to simplify. 3 squared is 9. 7 squared is 49. So we get the square root of 40. That's 4 times 10. So we could get 2 rad 10, or square root of 40 falls between 36 and 49. This is 7. This is 6. This is 4 digits. This is 7 digits. It's a little less than half, so I'm going to say 6.3, 6.4. I'm going to go second. And we get 6.32. So x is about equal to 6.3, 6 and 3/10, or x, we can say x is equal to rad 4 times 10, which would be x is equal to 2 rad 10. Now this is exact when we do 2 rad 10, because that 10 is an irrational number, and it goes on and on forever. Okay? All right, let's see what my PowerPoint did. Oops. It's going to open something up. I don't want to. Okay, let's see what, there we go. So they said about 6.3. I wanted you to, all right, find the length of a diagonal for a rectangle that measures 3 inches by 4 inches. So if the diagonal is here, this is what a diagonal goes corner to corner. Okay? So basically we're just looking for that. So if we know we're going to utilize, it's created by adding that diagonal, it's created a right triangle, so I can use my Pythagorean theorem. I'm doing 3 squared for A, 4 squared for B, and x becomes our hypotenuse. So it's 9 plus 16 equals x squared. I add them up. And then we root both sides, and x is equal to 5, which was one of our Pythagorean triples, but I do want you showing your work, okay? All right, so if I do the same thing, find the length of a side of a square whose diagonal. So we don't know the sides, we only know the diagonal is 4 this time. So I'm still writing a squared plus b squared equals c squared because it creates a triangle, a right triangle. And now I'm going to set my legs up as x squared plus x squared equals 4 squared. And when I have x squared plus x squared, remember, we're just combining like terms, and we're really just adding the coefficients. So that becomes 2x squared equals 16. I'm dividing both sides by 2, and then I'm going to root both sides. The square root of 8 is a little less than 3, so I'm going to say about 2.8, 2.9. Second square root 8, and I get 2.8. Good guess, Yamasaki. Okay, it's about 2.8. All right. To the nearest tenth of a foot, find the diagonal of a rectangle with a width of 4 feet and a length of 10 feet. So we want the diagonal. Okay, you guys are trying this one. All right, you should have drawn it like such. give yourself that visual in your notes while you're doing the homework. We're squaring 4, it's 16. We're squaring 10, it's 100. It becomes 116. I'm going to root both sides. And then we end up with 116. 4 goes into that 25. And 4 goes into a 25. Another 4. I'm going to break this down. Okay, 116 is less than 11, but more than 100. So it's 4 goes into it 29 times. So I could do 2 red 29, or we can do estimate this. 116 falls between 100 and 121. This is 11. This is 10. It's much closer to the 11. It's only 5 units away. And here it's 16. So I'm going to say about 10.8. 10.8 second square root 116. 10.77 is pretty close. So x is about equal to 10.8. And there we go. And I said 2 red 29. And by the way, when I'm doing these estimates, I have not looked at any of these answers yet. Okay, now they're going to put us in a word problem where we're situationally going to make a right triangle. A car drives 20 miles due east. Draw what they're saying. Then 45 miles south. Draw the distance of the compass of our little north, south, east, west. So I'm doing 45. To the 100th of a mile, how far is the car from its starting point? So we're doing a squared plus b squared equals c squared. We've got big numbers today. This is where your perfect squares are going to come in handy. So 20 squared is 400. 45 squared is 2025. Now, once I add those up, here's how I'm going to deal with these. I'm going to start with my tens, like 10 squared is 100, 20 squared is 400, 30 squared is 900, it's more than 30, 40 squared is 1600, 50 squared is 2500, so it's somewhere between 40 and 50. Now, I'm going to estimate it to a couple different numbers, because 40 squared, right, equals 1600, and 50 squared equals 2400. So I'm going to guess somewhere closer to 50 squared, like 48, 47. So I'm going to try that with my calculator. 48 times 48 is 2304. So it would even have to be higher because it's 24. So it's 40. It's only 75. I should have guessed better. It's about 49. You can break this down. We do know that 25 goes into it. So 25 divided by 25 is 25 and 97. So I could break this down to 25 times 97, which is 5 rad 97, or I'm going to guess 49 point, I don't know, I'm going 49 squared is 2401, so I'm going to guess about 49.4. There's 75. 49.3. I'm going to say 49.3. So second radical, 24, 25. 49.3 is it. Wow. So the thing is on your chapter test, you're not going to have a calculator. 49.3 is about equal to x. So did you see that? I'm looking at 49 squared, and it was 24. This is 2500. And this is 2401. So this is only about 25 away from 49 squared, and that's why I guessed 49.3. Got it? Okay. Well, you're not going to have access to a calculator on your final. Okay, find the legs of a right triangle if one leg is twice as long as the other. We're going to name it. we're going to call one x and the other 2x. Okay, we'll call the hypotenuse is 10. So we set that up. A squared plus b squared. So x squared. Now please pay attention here. Notice that 2 is squared and the x is squared. So that becomes a 4x squared. Altogether, when we simplify that, we have to add our like terms. That makes 1x squared. So 1x squared and 4x squared, that makes 5x squared. We divide both sides by 5, and then we get x squared is equal to 20. 20 falls between 25 and 16. It's 4 from 16. It's 5 from... So my best guess would be about 4.4, or this would be something, since we're really just finding out, we don't need to estimate it. We don't need to order, we don't need an actual distance. I would reduce that, so that would probably be 2 rad, 4 times 5, so it'd probably be 2 rad 5. Okay, so 4.4 or 2 rad 5, either one's good, unless they tell you. Okay. And so if x is equal to 4.47, then the other side, when we double it, we get 8.94. Okay? I guess we do need, because they want the measurement of both, and we have to apply it. So using the radicals wouldn't have helped as much. All right, this is a typical Pythagorean theorem problem. The ladder problem. You've got a wall, and then they lean a ladder up. They want to know how far must the base, this is your base, the bottom of the ladder, be placed away from the wall if it's to reach a height of exactly 10 feet. So I'm doing, we know it's a 12-foot ladder. They want to know how far must the base of the ladder, the bottom, that's our unknown. If it's to reach 10 feet, the height should be 10 feet. So we're setting that up with our, this is very typical that they use a ladder problem in Pythagorean theorem. So I'm substituting. Our unknown is a leg, not the hypotenuse. They give us 12 for the hypotenuse. We simplify those. 10 squared is 100, 12 squared is 144. Substituting. Square root of 44 is 4 times 11, so 2 rad 11, or 44 is just less than 7. But greater than, so I would guess that's 6.6, 6.7. Okay, estimated at about 6.6. Remember, I hold you to the nearest tenth. All right, a wire, another typical problem in Pythagorean theorem. Here we go. I've got a flagpole. I'm taking the wire, a guide wire, and I'm pitting it to the ground. A guide wire is needed to support a 20-foot pole. We know the pole is 20. How long should the guide wire be if it's to be fixed to the ground? 8 feet. We know the base is 8 feet. What we don't know is our hypotenuse. So I'm doing a squared plus b squared equals c squared. Okay, we're substituting in the 20, the 8. We're going to add it. We're going to root both sides. And we know that 21 squared is 441. So I believe it's going to be about 21.5. It's very close. All right. Or I could have reduced the radical. All right. In this case, we have a cube. Well, it's not a cube, a rectangular prism. We've got a diagonal we're calling x. Now, right away, what we want to do is create that little triangle here, okay? But in order to do that, we're going to have to find the dimensions of another triangle first, because we have those dimensions. So if I create that triangle, the dimensions that I have, I need 2 out of 3. I have this one right here, right? Because if this is 6, so is this. And now I know that this is 6. This has to be another right triangle here. So we have to find that first in order to find, oh, we know that as well. Oh, yes, okay, sorry. No, we're still going to have to find it. We know that that one there is, sorry, this is the right triangle here. I don't know what I was thinking there, because you can see it's cut off. All right, so we have to find that missing leg there in order to be able to figure out the red triangle we've created. So I'm going to first do my a squared plus b squared for the black triangle on the bottom, which would be 6 squared plus 8 squared. I believe it's going to be 10. Right, that's one of my Pythagorean triples. So if y is 10, right, now I have my 2 dimensions, so I'm able to find that diagonal of the rectangular prism. So I'm doing 5 squared plus 10 squared, and then I'm going to root it, and there we go. It's about 11 2/10. Okay? And that's our lesson for the day.